Welcome, everybody. Good afternoon, and hope you have a good session today. So today I want to take you on a small journey that starts with a familiar place and then leads us to an pretty extraordinary frontiers, where two different and groundbreaking technologies hold the promise for completely transforming our future. With that in mind, I want to present with this graph. So this is a pretty transformative graph. If you look at it, so on the bottom, you can see the time scale. On the y-axis, you can see the model parameters. And what it depicts is the monumental growth of the model parameters, both for the memory and the compute side, memory and the hardware side, as well as on the compute side. So this graph here, the straight line, represents the development on the memory and the hardware architecture. And this guy, which is going up, this is talking about the model parameterization. This is divided essentially into the two sections, the left and the right. And the left is known as the compute limited era, and the right is the memory wall or the memory limited era. And what happened up until 2019 was that the technological bottleneck was only up till the compute power that we have, not essentially the hardware or the technology that we could develop. But things shifted because the compute power caught up to what the actual technology was able to deliver in terms of the bandwidth and the hardware. And since 2019, you can see this explosive, exponential growth in the parametric requirement for these really latest AI technology and the sophisticated models that we are developing. From ChatGPT 2, it jumped to ChatGPT 3, 4, and now with the 4.0 as well. And what it does is that it requires the hardware and the architecture to be able to compute all of those calculations. But on the bottom side, if you see, although it necessitates the development of the architecture in which NVIDIA and AMD models has done in the last few years, which essentially skyrocketed their market value, they're still trying to play a catch-up here now. So the development of this hardware architecture is about 2x every 2 years. So it doubles every 2 years. In the same time, the requirements on the parametric development is almost 240x. So the disparity is not in the orders of 10 or 20x, it's 120x. What it means is that your future models require some sort of a breakthrough to go through this memory wall. Otherwise, you're limited in terms of the performance then. That's where I would like to introduce you to this next concept. So AI came to my aid to visualize what I wanted to present. So this is a 3D realistic image of the intertwined destinies between these two groundbreaking technologies, AI and quantum computer. Now, AI has this insatiable demand for the memory, compute, and hardware, and it requires somebody to break through those barriers, and quantum computing delivers that kind of a promise. It has the ability to perform extremely complex computation in unprecedented times. So there's a hope that you can actually develop architecture which can cater to the needs of that developing frenzy. And interesting bit is that this is a symbiotic relationship. That's what I tried to sort of predict that or present that in that image as well. It's a symbiotic relationship. It's not a one-way communication. So quantum computers, they can tackle the challenges which are intractable for the classical computer. So that's actually providing the horsepower which is needed to sort of fuel those parameterizations in the AI sophisticated models. But at the same time, they need the AI for the development of their own technology as well, whether it's on the algorithmic development, whether it's the quantum circuits, or even in the enhancement of the error correction techniques. All of that essentially is an indicative of the fact that these two technologies have to have this sort of a mirage in which they actually work together hand in hand. So because quantum computing already is revolutionizing most of the industrial parameters and is promising to deliver huge capabilities in the future, the talk that I have designed today is mostly to give the insights into the ecosystem of this development structure of the quantum computing and how organizations can actually adapt them. Not only simply navigate, but actually embrace them into their own ecosystems because of the regulatory requirements and the needs of the future. So let's delve into the nitty-gritty of what's needed for the eco-development and the sustainable adaptation of the quantum ecosystem. So I'll be talking about quickly ecosystem, then some of the main hurdles, organizational adaptation, and then the buy-ins. So why is it necessary, essentially, to look at these quantum computing? Because the solutions it's providing or it's expected to provide are already set to revolutionize the way we look at the world. And this is actually can be seen by the amount of commitment that we see from all around the world. Around $42 billion have already been committed. It's not a small amount, and this is the latest figure from the last year. And this commitment is not from a single company or a single country. This is over 650 companies, around 200 universities and 250 groups and corporations, and over 57 governments have committed to the development of these technologies. And the reason is because these are the only possible or viable option to bring about change in terms of the sustainable development and the quality solutions that the WHO and the economic forums have set around us. And as I said, this is kind of a universally distributed. China is leading this funding, but within the UK, around $8.4 billion have been sort of committed to the development of these solutions. And if you just combine China and EU, it sort of caters for around 2/3 of the entire budgets. And with that, UK is leading with a $4.3 billion commitment, about, I think, 1.2 from the last year only. So there's a huge amount of pressure to actually develop these technologies and bring about the change because this is the demand of the time. And the horizon line or the timeline for these developments is generally between a decade and a half. But with the progression of the AI in the last couple of years, this is looking more and more promising that we will be able to see something made much rather faster in the future. So if you look at the technological landscape here, so I don't want to confuse you or burden you with this information, but the point I want to make here is that this technological landscape is very, very diverse. It's not a straightforward thing for the people to sort of navigate through. So on the left-hand side, I've put the quantum pioneers. It's not an exhaustive list, just simply an indicative. Then on the pure play side, we have some hardware distribution companies on the software side. And then we have some pure SaaS companies which are providing quantum as a service solutions as well, online platforms. And all of they are based on some key different technological developments which are listed on the top. And we can separate most of these technologies into those developments independently to do where a lot of different companies fall into those categories. And this becomes pretty challenging for a normal organization to sort of find their way through this ecosystem and see where they fit in and which will be the best solution for them. I've listed some of the sort of a key adoption advantages and the markets where quantum computing essentially will be playing a significant role, leading from financing and banking to healthcare, communication, transportation, and logistics, mostly energy and environment, where quantum holds a significant promise, and then afterwards, finally, the security. And probably security is one of the reasons where there's a arms war almost going between different nations, that who's going to be the first one to provide a quantum cryptography. On all of these sections, major developments have been made in the last few years. Quantinuum is one of these leading companies which are talking about the quantum volume, which is a measure of the value of a quantum computer. And they have come up with significant breakthroughs up until 2023. They have promises to make around 1,000 qubits, which actually did try to demonstrate last year. And up to, in about 7, 8 years or 9 years, they want to make it up to around 100,000 qubits as well, which is like significant investment by 100 million into that as well. If you look at across the world, India already has implemented their quantum network-based communication network. We've got companies which are already demonstrating the qubit correlations or entanglement of the qubits on a long distances. What I'm trying to say is that this ecosystem is very healthy and very, very rapidly progressing across the world in different platforms. However, they're not away from challenges, and they're not as easy to overcome as a lot would envision as well. So I listed those mostly major problems into 4 categories: scalability, manufacturability, size, and cost. Most of the quantum computers struggle with that. There is no single company which doesn't actually provide a complete solution which can tackle all of these problems. How you scale that quantum computer is going to be extremely valuable. It's not, if a one quantum computer requires $10 million to build, how many can you build with this kind of a budget requirements then? Manufacturability, do you have existing technology to manufacture those devices, or do you need to build new technologies in order to actually scale them up? What about the size, how big that device is going to be? If its size is a problem, then you can't scale it. The bigger it is, the more space it would require. And finally, the cost. Everything is going to boil down to eventually the cost then. And all of these technical sides things aside, one of the key element of or one of the biggest hurdle in the quantum adaptation is the talent pool. There's a power play going on between the startup and the large-scale industry. So large-scale industries struggle with the talent, small-scale industries struggle with the finances. Smaller startups, they generally come out of the universities. It means there's a lot of talent pool which is coming out of those organizations, so they have an access to those people in local domains. Large-scale companies have to then fight for those sources and then get them hired. But if you look at just simply the market gap, there are around 350,000 people who actually possess similar kind of a skill set, not necessarily in the quantum, but they can be transferable to the quantum technologies. And there's a huge gap where there's a talent pool missing. So there's a hunger or the need from the industry perspective that you need to invest or transfer the skills from the alternative technological areas. And maybe I'll actually skip that because when I was doing this quantum landscaping, I came up with an ideal quantum computer and what it should have. Let's talk about the adoption. So this is a really interesting graph as well. So if you look at on that side, all the way left from the left to the right, around only 11% of the companies in the market space actually are using or deploying quantum computing solutions in their operations. About 17% are thinking that yes, they identified a use case and they might start deploying it, but overwhelming majority, around third of the population in terms of the organizational infrastructures in the market space, they have no clue about it. So about 75%, so about 75% of the market is not prepared for what's coming their way. They're not ready for the adoption of these technologies because quantum computing, when it comes along with the AI regulatory reforms, they will impose certain sanctions and requirements when it comes to the sustainable reporting or even the deployment of the certain technologies. And it will impact most of the industries either directly or indirectly. So the difference is whether you're going to be directly impacted or be out of the play business or out of play because somebody else has chained down your supply chain. So that's where this gap led me to start thinking about how to sort of build a framework to help organizations to come up with sustainable adaptation mechanisms. And so generally, if you think about an organizational journey roadmap, you'd start from the planning organization, but you actually go from the ideation, design, definition, design, deployment, development, and deployment stages. But before you go towards these deployment stages, or design and development and deployment stages, the most crucial element is the plan and organize and the research and explore part, which is in early stages of any journey. And this is where I would like to focus on today very quickly. I've classified that into these 4 different categories: assessing organizational readiness, then identifying the potential use cases, which is absolutely a paramount thing to do, then resource allocation for that use case so you can develop and deploy it, and finally the integration with the existing systems and processes. If I quickly go through that, in terms of assessing organizational readiness, I'm mostly talking about this collaboration among the industries. That rather than starting anything from the ground up by yourself, it's good to develop relationships and start collaborating with the industry stakeholders who already have the solutions in that domain. Then initiative focused on developing shared standards, open platforms, and interoperability, which enables seamless integration. And the most important thing here is the industrial standardization, then, which is missing currently in quantum domain. But you need to be, in terms of an organization, to take on board these new technologies. You need to be in loop in order to get ready for this kind of an organizational changes. The second thing is the identification of potential use cases. This can't be overstated. Every organization and their use case will be different, and identifying where you actually can benefit from either the direct adoption or the subsequently supply chain adoption of the quantum technologies. And it's pretty a diverse sector, as I said. So one of the things is to start developing in-house resources to be able to sort of navigate and guide you through these various approaches. Then you need to assess sustainability for the use cases, which is critical to ensure the successful implementation. And finally, the importance of the evaluation and adaptation. I'm not going to go too much into the detail because I want to spend a little bit of time later on a different topic, different part of it. So this part is mostly resource allocation and investments. I've also divided into the 4 categories inside where you have to build the in-house team and the resource, rather than having an expensive overburden of just negotiating and working with external partner. Having an in-house pool of the resource can help you sort of fasten this overall deployment. Then the clearly defining your own talent needs. You have the invest in the champions of the quantum computing. I came up with that based on some different industrial protocols as well, where you have a key person to drive that certain initiative and with the influence and with the direction inside the company. And finally, the pathway to the diverse talent pipeline. And this is much more linked, the last part is linked with the shortage of the talent. So you have your in-house talent already, whether it's a computer engineer, whether it's a mathematician, whether it's the analyst, or whatever, any other 7 or 8 other different categories. Rather than looking for the new talent, you can invest to upgrade them, upskill them. Most of these skills are transferable, and they can be in-house resourced in. And the final part is this integration, which is with the existing ecosystem. Nobody wants to adapt a technology which is in conflict with your existing running operations and the management systems then. So how well that technology can get adapted is going to be the key for this road. Secondly is the justified resource. You need to be able to justify why you're investing in this technology. Quantum computing, although it is a hefty business, but the end should you should be able to justify it in a sort of a financial term, the ROI, that whether it's an effective way to go down that organization for that route. Sustainability. So whether you do it in one way or the other, the end goal would be the sustainable adoption. There are sustainability directives coming out from the European Union, which are imploring the companies for adoption of the technologies in a sustainable way, which is linked to the carbon footprint. So one of the major or the fundamental things for most of the companies to assess would be how to transfer the carbon footprint, which is coming out of their products, generally using the quantum technologies which have not been offsetted. This four-pillar structure likely would then enable the sustainable adoption of technology like a quantum computing into your organization. Then, finally, I want to spend a little bit of a time on buy-ins. I think most of the people that I've talked to yesterday and today, they're from the sales side, and they would probably second me saying that if you can't have a buy-in in a company-wide culture, you cannot deploy any change. Even in a large-scale companies, it's a bigger problem. If you can't have the executives or the managers, and then afterwards they classify different sections and the departments, backing up what you want to invest in, what you want to do or deploy into the company, you can't even change the sort of a design of your desks or the workspace because people don't buy in. So one of the crucial elements of any organization is the knowledge and buy-ins, how you actually make people get behind the initiative that you want to drive. And the fundamental element is the awareness and the education. The second part, couple that with, is the stakeholder engagement. The third is the communicating the benefits and the ROI of these engagements, and finally building the quantum culture. So what I mean by the awareness and education is that most of the people are afraid of the new technologies just because they don't know about them. And this fear stems from this level of ignorance. And ignorance doesn't mean that it's something bad. It's just about not being aware of what the potential benefits are or what the technology or the initiative might lead the company towards. So as much of an information that you could actually provide company-wide, letting people come on board in terms of understanding and also follow through in terms of the development cycle, it's gonna make the life easier in terms of the adoption. The stakeholder engagement is extremely important as well because it's not only about a single person in the company. This kind of a large-scale investments or the adoption of the technologies requires engagement at all levels in terms of the inside the company. Even if you are implementing a CRM, you need to get a sort of a really strong engagement and the stakeholder engagement from the customer side inside the company as well as on the management side and the external collaborators. Another thing important in terms of the benefit side is the ROI. So whatever you do, there has to be a bottom line. So it's not about just simply investing into the future with no potential return or the path to the returns. So how do you measure those returns and indicating or sort of openly discussing and showing that to the stakeholders is probably a major part of that organizational buy-in plans. And then the culture. So more you talk about it, the more you build a culture of adoption, the more you open up people towards possibilities of the new technologies and what they hold in terms of possibilities and the promises for the future. So with that, I'll just leave you with the last summary with the 2 or 3 main points. Quantum computing is set essentially to change or transform our future. But it's not without the hurdles and the problems. It requires a sustainable framework and a plan to get them adopted into the industry. And I'll leave you with that. If you have any questions, I'm open to that. Thank you. Oh, and just lastly, so you can scan that in case you need to get in touch with me or you need any help, please feel free to get in touch.
In terms of questions, our Slido is dead, okay? So the gentleman who's sticking his hand up is doing exactly the right thing. Then we'll get a microphone to you in a moment, sir. If you could just identify yourself, ask your question. Thank you.
Hi. My name's Jonathan Stevens. I'm a software developer. Where are we at with interfacing with quantum technology? So let's say we've got a bunch of data in a database. We want a number to come out of analyzing that data. What have we got for interfacing with current technology with quantum computers?
Right, so the purpose of quantum computers is to solve what classical computers cannot. So this is another tricky thing for most of the organization would have to deal with. The decision of whether to actually embark on the journey of adoption or not, right? You don't want to invest into the technology which classical computing can already offset it for you. So if you have AI algorithms and you have the machine learning part down, you have the sophisticated analytical tools, you can actually get those numbers without actually the adoption of the quantum computing. You don't need to go down that path. So the purpose of the quantum computing is to sort of facilitate the calculations, solve the problems, the biggest problems that humanity will ever face and have been facing, the things which have been out of reach from us for the long time. Whether it's the optimization of your logistics, it's the food problem. I'm just skipping a few, but the point is that anything that you don't need to invest into significantly and you can actually get your answers with the classical computing, there's no need for quantum computing. Quantum computing comes when your classical computer fails. The problems which are intractable by those approaches, that's where the quantum computing supplements them then.
Is that part of the reason why quantum computing is a really difficult concept for some people to get their heads around? Because if you don't know the question to ask, how do you know where you're going to find the answer?
You're absolutely right. And this is where the problem of this adoption comes in because people are not aware of it. 75% of the market has no idea about quantum computing. And I can tell you, even a brick and mortar company will be affected and disrupted by the quantum computers in the end. The reason because the quantum computer will change the way we optimize and formulate the processes and materials. We will come up with a new optimized systems and the industry which will be implementing those cements or different manufacturing system, that will be completely revolutionized. So a brick and mortar guy will have to make a decision at the end whether to actually go with one or the other. Then one will be better, it will be cheaper, it will be much more affordable and much more better in terms of its property. But because people don't understand their own organization's position in the ecosystem of the quantum computing, they fail to understand the implication and the impact it will have down the road in the organization.
How do you go about trying to explain this to muggles?
Sorry, to mother?
To people who are not in this field. Who
Oh,
don't
muggles,
understand
right. Harry Potter reference. I thought you were talking mothers. Right. Yeah, I think the education. Yeah, so one of the things, so you see, you have not actually tried to use quantum jargon in the conversation, is to break it down as simply as you possibly can for the people so they can relate to it. It's considered something which is out of reach for most of the people because of the word and the scientific knowledge required for the development part. But you don't need to be scientifically literate to adapt the technology. How many of you have actually built the AI models themselves? But how many of you, great, how many of you have been using ChatGPT? You see, you don't actually need to have this knowledge to be able to work with the technology to actually adapt it. The fear is that people have not been educated well enough to actually tell them that it's nothing to be afraid of, it's something to get value out of and use it in your lifetime.
No, I absolutely agree. You know, the vast majority of these people in this room will have a driving license. and have no understanding of the working of the internal combustion engine, it doesn't
Exactly.
matter.
Yeah.
As long as you turn the key and the damn thing goes, it's fine.
Yeah.
Any other questions from the floor?
Yes.
Lady there, please.
Oh.
So just keep your hand up, please.
Afterwards,
We'll
afterwards.
get a microphone to you just in a second. Right.
There's a guy in front of me, so you can speak up
No,
louder.
just say, you can see this. Sorry. Whoa. Sorry.
Sorry,
This lady-
conflict of interest there.
Middle row. Keep coming. We wouldn't hear that gentleman without the microphone.
The example you gave around, how many of us have built AI versus how many of us have used ChatGPT. I think the main success of GPT was the very simple user interface.
Absolutely.
It brought what interfaces does the common person have to interact with quantum computing?
Nothing. Very good question. Nothing at the moment. And this is another challenge, right? Because most of the companies or the work that has been done by the companies. This is done in these little silos. Quantum computing has been perceived as a race. Who's going to be there first? AI was not developed like that. AI was developed for the mass adoption as an early stage. The difference between AI and quantum computing adoption is that one is deliberately designed to help every person, layman, in their daily life use cases. Quantum computing is not designed for that purpose. It's designed to solve the biggest challenges in the world, not to cater to the masses the way the AI is designed. So when you talk about the drug discovery, when you talk about the treatments which are really untreatable today, and the reason they're untreatable because we don't have the mechanism we can run the simulations on a large-scale basis to come up with the most optimized recoveries, and quantum computing will change that. It will allow you to computationally deliver those solutions at a much more faster pace. The impact would be, for example, one of the largest carbon footprint producers in the world is the travel industry. We travel all around the world using our cars and our planes, but they have a massive impact on the global CO2 production systems. And most of the time, most of that CO2 comes from the wastage because these planes are either flying in the air, just burning after fuel, or they're just actually not routed in a much more effective way. The same goes with for example, Amazon. How many of us get these Amazon parcels on a sort of a daily basis, right? All of that fleet needs to be optimized on a large scale, and we don't have the computers or the systems at the moment which can do it for us. So these big challenges are the ones where the quantum computing focus had been. But down the road, what will happen is that they will translate into these mechanisms where smaller organizations will be able to access them rather than having to develop them themselves. So you will have these online platforms, for example, like Amazon has or Microsoft have, and you could only simply go on there, define your problem, and it will spit out a solution for you then.
Okay. Give this gentleman, have a microphone. You can ask a question in that.
Yeah, so coming from more of a physics background, I know about the actual physical problems with the development of quantum computing. So do you see in the future any actual return on income or return on value from these smaller companies trying to develop in-house solutions as opposed to just using these cloud solutions for everything?
What kind of solutions?
If small startups are trying to compete with their own quantum computing models, do you see that actually getting anywhere for the next 20 years? Is everyone just going to be using these cloud models?
So it's almost the same as with any other technology. So it's like betting on a technology. If a startup is starting something, it means they believe that the technology or the steps they are taking will be better than the alternatives available. Which one is going to win is a question of time. If I had that crystal ball, I would have invested in NVIDIA 2 years ago, which I don't have. Yeah, so the short answer is that nobody knows. The time will tell. If one believes in it, they will just invest time and the resources to see it through.
Okay, thank you very much for that. Any other questions? Gentleman there with the beard.
Oh,
somebody right at the back there. Off you go, Maggie.
Hello, hi. I'm James. James from Craft Prospect. I'm sorry I missed the beginning of your presentation, but did you mention that? I mean, the main thing about the difference between quantum computing and classical is the fact that it's not just 1 and 0.
Sorry, come again?
So, sorry, I missed the beginning of your talk. But did you describe one of the advantages of quantum computing as the fact that it's not just 1s and 0s? You have the in-between states.
I never went into that technical.
Because that's probably the biggest advantage. So all binary computing is 1s and 0s. So quantum computing has different levels between 1 and 0, and that's the big advantage. So you can have a lot less nodes or qubits or cores if you want to compare it to classical, but each one is much, much more capable because it has these different levels between ones and zeros. And I think from kind of my company's perspective, we're focusing on the risks of quantum computing. And one of the biggest fears is the fact that quantum computers, if they're powerful enough, will be able to decrypt public key encryption. So that's a big threat to financial services, medical records, and it's not just a kind of 5-year away problem. It's a now problem, and the reason being that the prediction is that in 5 years, say the quantum computing will be able to decrypt existing encrypted data. So you have to kind of do it now. It's a now problem, not a 5-year away problem. The risk factors associated with quantum computing. So you have the post-quantum cryptography that's trying to, replace existing encryption. You've got quantum key distribution.
Yeah, got it.
Which transmits quantum-based keys instead of kind of classical keys. So I think the reason, one of the big potential uses, unfortunately, is bad actors trying to get access to data, financial data.
Sorry, is there a question?
Yeah. So the question is that you didn't really talk about the kind of any of the risks associated with quantum computing.
Yeah.
Really
Okay.
Just all the potential advantages. That's behind.
Got it.
I think we'll probably take that as a statement rather than a...
Yeah.
Thank you very much for that. Lady, just directly in front there, please.
So when we were talking about all of the different countries that are kind of racing to get this technology in place, do you think there'll be the governance or the willingness to share that technology when they do get it? Or is one country going to become a super country, superpower?
Yeah,
over
so
everybody else?
very good question. This is actually tied back to the statement from the gentleman just before you as well. So security is one of the reasons which is actually putting countries in race to win this game about quantum computing, because any country which will have this technology first will be able to decrypt most of the encryption technologies which are available at state of the art today. And the gentleman rightly pointed out that this is a big problem and a threat, and it comes with that, you can say, I highlighted all the positives only, but because the talk's perspective was about the organizational adaptation, not about the risks that had come with it. All technologies have the downsides. It doesn't mean that it will not happen. Just because that there is a risk, it doesn't mean that quantum computers will not be developed or the countries will not be investing into it. The point about the collaboration is an extremely important point, and I raised this with our quantum ambassador in Innovate UK meeting as well. That why is it that it's about the race and why is it not about collaboration? So I think on a larger picture, there is still this fear that it's us amongst them kind of a mentality, and it needs to change. Unless we do that, we will always be fighting against our second nation, whether it's the France or it's the Middle East or in Asia and China, for example. So these Cold Wars are like human nature driven. So I don't think I have an answer for that. If I had, I would have cured it, but I don't have it. So besides that, I think it's only what we can do is hope that we come to the common grounds. And as these companies or these countries are starting to invest more and more, they see as a financial risk as well. So if they invest and they're competing, one of them is going to fail. So it's also financial risk is a good motivator to start collaborating together to enhance the chances of success then. So that's where the huge investments and these collaboration platforms come in. But you're right, there's no straightforward answer to compete versus collaborate.
Faisal, thank you very much for that.
I'm
I'll
sorry.
get the microphone back.
Oh, there's one last question from this young lady.
Oh, right, fine.
Yeah, last one.
I realised there was another one there, right? But you can't right now.
Okay. Hi, Dr. Kamran. I'm Rachel from Shanghai, China. We are a startup doing the cloud computing service. And my question is that...
Sorry, which service?
Cloud computing service. Yeah, but all our is like CPU, GPU, like not QPU yet.
Okay.
So still not yet. Our customers all like drug design, biotech, chip design, semiconductor, even smart manufacturing. So my question is that, do you think quantum computing will be really helpful for drug design or biotech?
For biotech,
Yeah,
absolutely.
It's a huge market. It's huge market, but does it
Yeah,
really help?
quantum computing will have a significant impact on the biomarket, and the reason is because of the drug discovery, cellular analysis when it comes to spatial genomics. So it will be able to map the genomes in a way which current classical computers are unable to do that, or in the time frames that they're not able to do that. When it comes to drug discovery, currently the process of a drug discovery is around, I think, 50 to 20 years. We can't wait for that to run a second trial. One of the reasons cancer is not being cured so far is because we don't have the computational power to run different analysis or simulations at the same time. So in a biomed field, definitely quantum computing has a significant impact down the line.
I hope that answered your question. Faisal, thank you so much again. Thank you.
Thank you.